Professor, real quickly.
Yes.
So the 7th, October 7th is the midterm, right?
So today is Tuesday, September 28th. Yeah, October 7th. That weekend,
Okay, perfect.
that weekend will be the midterm, right?
The week. Okay, thanks.
Right. So let's open up the quiz. So this is quiz number 3 that was due today. So let's go ahead and open it. And I will share my screen here. Okay. So let's start. So this is quiz. Oops, we got quiz number 3. Should have it open in front of you. It says here, in a group of 100 students, 35 are juniors, 60 are female, and 22 are female juniors. So what I like to do, and the second question actually requires you to do it as part of the assignment. This one does not, but it's a good idea anyways, is to make a Venn diagram. Whoa, that was cool. But make a Venn diagram. And we have the circle that represents the juniors, and we have the circle that represents the females. And we know that there's 22 people that are both females and juniors, which means they fall in the overlap. And we know that in total, there's 35 juniors. So we already have 22, leaving 13 more for a total of 35. And there's 60 females. We already have 22, leaving 38 for the total number of females. And if I add this together, 13, 22, and 38, I get 73, which means the other 27 people must be out here. Does that make sense so far?
Yeah.
I haven't even looked at the question yet. I'm just drawing a picture to represent what's going on. So then it says, what is the probability that you get a junior or a female? So one way would just be to count all the numbers that are juniors or females, 13 plus 22 plus 38, and divide that by the total number, which is 100. The other way is to use the addition rule, which they specifically asked for. The probability of being a junior plus the probability of being a female minus the probability of being both a female and a junior. So what is the probability of being a junior? Well, 35 out of the 100 people are juniors. And how about being a female? Well, 60 out of the 100 people are females. And then a female junior, 22 out of the 100 people are those. And you get 73 over 100, or 0.73, or 73%. I will have accepted any one of those 3 as your answer to that question. Does that make sense for number 1?
Yeah.
Yes.
Of course, if you just add up 13, 22, and 38, you do in fact get 33. Question 2 said, or read, in a group of 80 students, 30 use Facebook and 40 use Twitter and 25 use both. So again, I'm going to make a Venn diagram. This time it says make a Venn diagram. So again, I have 2 circles. I have my Facebook circle and I have my Twitter circle. I always start with the inside, 25. 25 use both. Now, what I saw a number of people do, which is wrong, is they said, oh, 30 females and 40 Twitters. So they put a 30 and a 40 there. Now, even before I go any further, if you add up those 3 numbers, what do you get?
More than 80.
More than 80. So that can't be right. I don't even care what the number is, but it's certainly more than 80. And the mistake is exactly the same as the previous problem, that when there's 30 females, you've already written down 25 of them. Not females, I'm sorry, this is Facebook. When there's 30 Facebook users, you've already written down 25 of them. There's only 5 more. The entire Facebook circle is 30. The 25 that happens to overlap with the Twitter, and 5 by itself. And the entire Twitter circle is 40. So how many are left after the overlap?
15.
15. Now between them, that's 45. Correct?
Correct.
And there's 80 students in total. So how many are left on the outside?
35.
35. So the question then says, draw a Venn diagram. How many students use neither? Well, there it is, 35. A lot of people wrote 10. A lot of people wrote 10. They did 30 for this and 40 for this, but I still am not quite certain how they got 10 as their answer.
Well, they added 30 and 40, getting them 70.
Right.
Getting
about-
left for 10.
What about the 25? They just ignore that.
They just didn't count it. So they added the Facebook and the Twitter, and then they just left. You get what I'm saying?
I guess that makes sense. 30 and 70 is,
And then the other 10 students use neither, you know?
yeah, I mean, I guess it's obviously wrong, but it's always better. It's always better to be wrong with logic than it is to be wrong with nonsense. Okay, even if your logic is wrong, and in this case, what you're saying is wrong, but at least there's an approach to it. No, but at least there's an approach. At least there's a reason why you wrote what you did. Sometimes you write an answer down. It's like, where did this come from? And it's like, I had to write something, so I wrote this down. It's like, no, okay. Even if it's
Yeah, because
wrong.
reading it says in a group of 80 students, 30 use Facebook and 40 use Twitter. And it
Right.
doesn't say what the other 10 use. So I'm guessing they said the 10 use.
No, there was some math involved. I always looked at the math, and unfortunately, the math
Oh, okay.
hard to decipher. I spent so much time on that problem, and I knew I had to be over. Yeah, these are none of the problems in this course. None of the problems in this course should require too much mathematics. Even as we go further in the chapters and they get more challenging, none of them should require too much. So if you're spending a lot of time on something, chances are you're not looking at it in the right way. Anyways, that was the quiz. Hopefully it made sense. Any questions on it? All right, let's have another quiz this coming weekends. And this one was on what chapter? Was this chapter 4?
Yes.
So 5 and 6. So the next quiz will be on either 5 or 6. I get to decide
Okay.
because 5 and 6 are kind of connected. So either 5 or 6, the next quiz will be this coming weekend.
You'll tell us which chapter on Thursday, yeah?
No, it's either 5 or 6.
Oh, okay.
I'm not going to tell you. What I'm saying is I get to pick at the last seconds, or maybe I'll even pick one question from 5 and one question from 6. I don't know yet,
But
but
you're gonna put the solutions for the homework, so we know that we're doing them right.
yeah. I mean, I have the first 4 chapters up. When does chapter 5 homework due? When did I assign the 5 homework? Did I give a due date for that?
No, you didn't.
No, you didn't.
Okay, well then 5 and 6.
So let's just say
Um,
today 5 is due and then Thursday.
Well, I mean, the homework is, the first day I said this, homework is due a week after we finish the chapter.
Okay.
So that was from day 1. So chapter 6 we finished last time, which means the chapter 6 homework is due Thursday.
Oh, okay.
So 5 would have been due either today or maybe last Thursday. I don't remember when we finished 5, probably last Tuesday. So
Okay.
officially 5 is due today. 6 is due on Thursday, and the quiz on 5 and 6 will be this coming weekend.
Perfect.
Okay, and I will put the solutions up for 5 today. Let me just write that down.
And then for 6 on Thursday.
And I'll do 5 today and 6 I'll put up on Thursday
Sounds good.
for math 211. Okay. Okay, and then for now, we are going to start chapter 7. So let's load up chapter 7, the file, and Natalie Sorio is here. Okay, I'm gonna let me attendance. Hold on a second, everyone, and then we will go on to the next chapter. Today's the 28th. Okay. Maya, Fritzy, Katarina, any of you here? Okay. And Aubrey, are you back yet? No, it's not back. Okay, so math 2. Okay, so let's go chapter 7 now. Load files. I'm gonna share my screen, so let me unshare this and chapter 7 PDF. Okay, so let's load up my screen here. And let's get started. Okay, expected value. Expected value is a very important concept in probability and statistics. It's also a quite often misunderstood topic. So let's take a look at this first little exercise. It says each student in a class flipped a coin 10 times and counted the number of heads, and the results are recorded in the table below. So how often, oh, someone's chatting already, what do they say? We don't have chapter 9, right? There are some chapters that I'm skipping. So if it's not on the files, we're not going to do it. I think 9 might be the first one. I don't remember exactly, but certainly a possibility. So, okay, so how often were 0 heads showing when people flipped 10 coins, according to this chart? How often did it occur?
0.
Never happened. Never happened. How about one head? How often did that occur?
Never happened.
Never happened. How about 2 heads?
1.
Once, and 3 heads,
1.
and so on. So the question is, what is the average number of heads among the class? How would I compute the average number of heads?
Wouldn't you add them all up and then divide by 10?
Well, why by 10? Were there 10 trials?
Or the number of times that you got heads?
Well, 1 second. We got to be very
Oh,
careful.
wait, 11.
So you want to divide by 11 because there's 11 possible outcomes, right? 0 through 10, right?
Yeah.
But that's not what you're dividing by here, because you're dividing by how many people there were. Every person got a number from 0 to 10, correct? Or in our case, 2 to 8, but in general, every person got a different number, right?
Yes.
Okay, so what we're dividing by here is not by the number of possible heads. We're dividing by how many people there are in the class. Because each person, in some sense, is a test. And if you want to find the average of your test scores, you divide by how many tests you took, correct?
Yes.
So I'm going to add up. What numbers am I going to add up here? Start reading them off to me, the numbers that I'm going to add up. And this goes for everyone, not just the one on the hot seat.
2 plus
Two.
1.
Sorry, say again?
2. Are you going to add 2? 3, 1 plus 1, right?
I'm sorry, hold on. I'm Genesis. I'm so sorry. I love that you're contributing, but with the talking in the background, it's hard to hear. I mean, I love people answering, but it's very difficult because there's like children in the back. Is that my imagination?
Yes.
Oh, it's just hard to hear when they're talking. But okay, so what numbers am I adding up here, everyone?
Is it 1 plus 1?
Why, where do you get 1 plus 1 from?
Is it the tallies, or is that what you're adding? Or what do you mean?
Well, that 1 that you just read off, what is that a tally for?
The number of
How many
heads.
times
How many times?
we
You got a number of heads when number of heads.
Wouldn't we add 2 plus 3 plus 4 plus 4 plus 4 plus 4 plus 5 plus 5? We just go through the tallies.
Yes, the single tally mark down there is representing 2 heads. Somebody got 2 heads once. So what I'm adding here is 2, 3. How many times did I get 4?
4
Four.
times.
So a total of 16 heads there. How many heads in this category?
25.
25. How many in the next one?
30,
30. How many in the next one?
28,
And how many in the next one?
8.
So that's how many heads I have in total, correct?
Oh, okay, I see it.
So 2 plus 3 is 5, 16, 21, 25, 46, 56, 66, 76, 86, 96, 104. 104 plus 8 is 112. There's 112 heads in total. And how many people are there flipping?
$21.
21. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So when I do 112 divided by 21, I get 5.3 repeating. 5.3 bar is the number of heads per flip on average. Does that seem reasonable that 5.3 bar, 5.3 approximately, should be the average number of heads when I flip a coin 10 times? Does that seem like it's ballpark of what the answer should be?
Yep.
Sure. What should the answer be, by the way?
5.
Yeah, in a perfect world, I would expect to get 5 heads, correct? On each time, right? Everyone? Anyone? Bueller?
Yes.
Okay. So in a perfect world, I would expect 5 heads, 5 tails, because it's 50-50. So 5.3, I mean, it's not a perfect world. You know, obviously, I got 2 once, and I got 3 once, and 8 once. Is that always going to be 5, 5? But as long as I'm somewhere in the vicinity of 5, I shouldn't be too surprised. Does that make sense?
Yes.
Okay, so if you get an enormous group of students, each to flip a coin 10 times and add the results like we did in the table, what do you think the average number of heads would be? If we had an enormous, not 21 like we did here, but enormous number, what do you think it would be?
Closer to 5.
Closer to 5, right? And in fact, this is kind of like what the law of large numbers says, right? That as the number of flips goes up, as the number of trials goes up, we should approach stabilization around the true value. Does that make sense?
Yeah.
Okay. So if you roll a die, new question. If you roll a die 60 times, the expected number of times that you roll each number should be 10. Because again, 6 sides, each of them equally likely. So what do I expect to get without actually doing the experiment? It makes sense to say 10 each, correct? Yes, no, maybe so? Anyone here?
Yeah.
Yes, guys, go ahead, have like, you know, some kind of verbal or
Yes, I am here.
visual acknowledgement of my existence would be wonderful. Okay, now, do I expect to actually get 10 of each every single time?
No.
No, but if I do lots and lots and lots and lots and lots of rolls, it should probably be in the vicinity of 1/6 of 1, 1/6 2, 1/6 3, 1/6 4, 1/6 5, and 1/6 6, right? That seems reasonable.
Yes.
So what the expected value is, this expected number or expected value, this idea of this chapter, expected value, is essentially what do I expect to average in the long run? It says nothing about one particular roll or flip or toss or whatever your experiment is, but the expected value is a long-term result. And luckily, there's a very precise mathematical way of getting it, so you don't have to really even think about what it is that you're getting. You could just do the math and get it. But however, if you just do the math and get it, you might not be able to extrapolate that to a more sophisticated question. Whereas if you understand what it is that you're doing, maybe you'll be able to. So we're going to get there in a minute. But for now, if you roll a pair of dice 90 times, What is the expected number of doubles?
I would say like 25-ish. maybe.
25-ish, which, just so you know, is not the correct answer, but, can you at least explain why you get that so we can see why you thought what it was? Maybe there's erroneous understanding somewhere, or maybe it was a silly mistake. I don't know. But if you tell me why you said that, maybe we can.
Well, I mean, it's not as likely to get a double, so I wouldn't say it would be like, around 40 or 50.
Okay,
So that's why I just kind of went like 20, 25.
25. Okay, let me see this question. How many different outcomes are there when you roll a dice, when you roll a pair of dice? How many outcomes are there?
6.
When you roll 2 dice, I don't think so.
Oh,
30,
12.
36.
36.
Oh.
Remember, we're not talking about the sum. We're talking about the outcomes themselves. 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, and so on. Now, by the way, Genesis, you are correct, but that's when I finish this. Of those 36, how many of them are doubles?
6.
6. Do we agree?
Yeah.
So what is the probability on one roll of getting doubles?
1/6
1/6.
or 6 out of 36.
Yeah, 6 out of 36, which reduces to 1/6, correct? Which means if you think about it, what do I expect to get? I expect to get doubles 1/6 of the time. Right? On average, every 6 rolls, I should get doubles 1 time out of 6, right? Well, if you get 1 out of every 6, what does that translate to out of 90?
15.
15, because 1 over 6 equals 15 over 90. Does that make sense? Yes, no, maybe so?
Yeah.
Okay. Genesis, I know you can thumbs up because you got the right answer. So I know you're on point, but I want to make sure everyone else is as well. Addison, let's hear your little chat message, whether you got it or not. Did I say you will? Let's hear the chat message. Okay, that didn't make any sense, but Addison, you there? Uh-oh. Did she leave? Hi. You get it? Not answer. Yes, good, excellent. Okay, so complete this formula. If the probability of a success on each trial is P, and you perform N trials, the expected number of successes is going to be what? And I want you to compare this to the previous problem, where in a previous problem, we did 90 experiments, 90 trials, with a probability of success on each trial of 1.
Frozen, bro.
What happens? Am I frozen?
No,
No.
you're good.
Okay. We multiply. So what should the answer be?
P times N.
P times N, or N times P. N times P kind of rolls off the tongue a little better. So most books, in fact, every book I've ever read would say NP. I've never seen PN. What a horrible answer. No, I'm kidding. I'm kidding.
I apologize.
It's okay. I'll forgive you this time. Okay, so NP is the expected number of successes when you perform N trials with a chance of P each time. So for example, if you flip a coin 5 times, what is the expected number of heads?
Two and a half.
2.5. Do we all agree with that?
I know you can't get half a head, but
Hold on a second. Hold on a second. Do we all agree if you flip a coin 5 times, a fair coin, of course, that according to the formula above, the expected number of heads should be 2.5? Anyone?
I do.
Does everyone agree with this, with the math giving you 2.5?
So you would do
5 times five times a half. Right, Genesis, 5 times a half?
How do we get the half? Like
What's,
one
Or
half,
pennies.
like the half.
what's the probability of getting a heads if you flip a fair coin?
Once, because it's just one head.
Wait, what's the chances of getting heads if you flip a coin?
One. I think.
Wait.
I don't know. Two?
Hold on. You are guaranteed to get a head if you flip a coin?
No.
So what is the chances that you get a head? If I flip a fair coin, what's the likelihood that it comes up heads?
50-50.
So as a fraction, what's the likelihood?
1/2.
1/2. Right? 50-50 is just another way of saying 1/2, right? 1 out of 2, correct? 2 outcomes. We want one of them, 1 out of 2, right?
Yeah.
And how many trials are there?
5.
5. So if we follow the rule that we had above, then the answer should be 2.5 heads. That's what the math gives us, correct?
Yes, makes
Okay.
sense.
So the question is, did we make a mistake in the math? Or did something go wrong? Because how exactly do you have 2.5 heads? In fact, students of all ages commonly answer the previous question by saying 2 or 3 heads because you can't get part of a head. How could you help them? Because here's the answer. The answer is not 2. The answer is not 3. The answer is 2.5. I expect to get 2.5 heads. Now, remember what I said earlier. Expected value says nothing about any one particular trial. Expected value is only a long-term result, which means if I gave you $1 for every head that showed, then how many dollars would I give you on your first flip of the coin 5 times? What are the possible values that I would give you? You flip a coin 5 times. Give me all of the possible values that I would give you in dollars. Can I give you nothing?
Yep.
Can I give you 1? How about 2? How about 3? 4? Yes, no?
Yep. All the way to 5.
All the way to 5. Now, would I ever give you $2.50?
No.
No. Well, let me ask you this question. If you perform this experiment twice, and I gave you $3 one time and $2 the other time, how much have I given you altogether?
5.
So how much have I given you on average per trial?
2.5.
2.5. So even though I didn't give you 2.5 on any one specific trial, the long-term average can still be 2.5. Expected value is all about long-term averages. It's never about what you get on this specific trial. Now, they're probably going to be close to each other, but they don't have to be the same. Does that make sense? Questions, comments, allegories, similes, metaphors, remarks, exclamations? Any English majors here? What did I leave out?
You missed anecdotes. I'm not gonna get
Anecdotes.
paid. You hit that one every other time.
Have I? Wow, shit. Okay, anyways. All right. So now, so someone said perfect, makes perfect sense. I hope everyone who's paying attention feels that way. If you're not paying attention, what can I do? All right. So now, fair price. Okay, the fair price for a game is the price that should be charged so that in the long run, the players come out even. Okay, if the casinos always charged a fair price, what would happen to the casinos?
There would be no casinos because they'd make nothing.
Yes, they would make nothing. So there'd be no advantage to owning a casino, to running a casino. So the casinos intentionally always tilt the odds in their favor. Now, it can't be too much in their favor. If it's 90-10, people would lose so much that they'd stop going. So do you know what the casino odds are approximately? Enough for them to make millions, if not billions of dollars per year. Do you know what the odds for a casino in most games? About 51-49. Okay, just being a little bit more than even is enough for the casinos to make a ton of money. If it's too much off of that, then nobody would play. Yeah, okay. I mean, you play blackjack, for example, or roulette or craps, and you do the right move every time. And by the way, there are books. You can even come to the table and sit down with books that tell you what the right move to make is. Hell, if you go to the casino and you're not sure what to do, you can ask the dealer and say, what should I do here? And he'll tell you the right, or she will tell you the right move. They don't care. They don't care if you win or lose because they know that in the long run, they win. So a fair price means nobody wins. We come out even. So let's do the following example. Suppose that your school holds a fundraiser in which 3 prizes will be raffled off. A $500 bicycle, a $400 iPad, a $100 video game. 250 tickets will be sold. What is the fair price for a ticket? In other words, find the price so the total money won is equal to the total money that's given.
Or to find the
Yeah.
sorry.
Go ahead.
I was wondering you have to find the fair price where you have to add all the prizes together to be
Okay.
able to get the fair price.
That's a great start. So if I add up all the prizes, what do I get? $4 is correct, by the way, but let's get there. If I add up,
1,000.
if I add up all the prices, I get $1,000, correct? 500, 400, 100, right? Yes?
Yeah. Yes.
So that
Yes.
means the people running the game need to spend $1,000 to buy their prizes, which means they better make $1,000 so that they can buy the prizes. So if there's 250 tickets, each ticket must cost how much?
$4.
$4. $4 per ticket gives exactly $1,000 earned, exactly $1,000 spent. Hey, it's a fair game. Now, if you were running this raffle, how much would you charge per ticket?
This is for a fundraiser, right? So more than $4.
It's got to be more than $4, but it can't be too much. Like if you spend $1,000 per ticket, no one's going to buy it, right?
Yeah,
Hey, even $500 per ticket is nonsense because why would anyone spend $500 to win a prize that's no more than $500? Okay, so personally, if I was doing this, $5 or $6. Okay, you're not looking to make a ton of money on any one ticket, but being just a little bit over even, you'll make money in the long run. Does that make sense? Yes, no, maybe so? Everyone?
Yes,
Yeah.
yes.
Okay, so let's go here. Let's do a new one here. Oh, this is a fun one. So I don't know if this is still on the air, but it was when I was a kid. Deal or No Deal. You guys ever hear of the TV show Deal or No Deal?
Yeah.
yep.
Everyone here knows how to play it? Okay. So just in case anyone does not, 26 briefcases contain various amounts of money as shown here. At first, one of the briefcases is chosen. So you're playing a game. Now you don't see those numbers. You don't know how much money is behind any one of them. So all you see are 26 briefcases, and you pick, let's say you pick this one. You pick the one that has $300,000 behind it. Now, of course, you don't know that it has $300,000 behind it. You're just picking a random suitcase. So at first, one of the briefcases is chosen and remains unopened. So we're never going to see this. It's unopened. Okay, with me so far?
Yes.
Now, every round, you pick a different briefcase, and that one is opened. So suppose I pick $1. Suppose I happen to pick the briefcase, it's $1. The host says, do you want the dollar, or do you want to stay with the one that you first originally picked? So you don't know that it's got $300,000 behind it. For all you know, the one you picked is 1 cent behind it. But what would you do? Would you take the dollar, or would you keep playing?
Keep playing.
Because chances are that the one that you originally picked has more than $1 behind it. What if the second briefcase that you picked had $100,000 in it? And you open $100,000 and the dealer says, do you want to stick with $100,000, or do you want to switch to the one, sorry, do you want to keep your original, or do you want to switch to $100,000? What do you do in that case?
Keep the
Probably
100.
stay there. Yeah.
Yeah,
I
in
would keep
that, in that case, it's much more likely that the first one you picked is one of these than it is one of these. Correct? Okay, it's a little more complicated than that, because quite often what happens is they, they offer you, an incentive and they'll pay you this amount of money because I don't know, it goes into more details, but we're not going to worry about that. For now, we're just going to do very simple. What is the probability that the first unopened briefcase is worth at least $100,000? What is the probability that the first unopened briefcase is worth at least $100,000?
7 out of 26.
Well, let's take a look. 1, 2, 3, 4, 5, 6, 7. 7 briefcases satisfy the condition at least $100,000. 26 briefcases in total. So 7 out of 26. Make sense?
Yeah.
Okay. Now, a player could keep the first unopened briefcase until the game ends. What is the average amount such a player wins? A player could keep the first unopened briefcase until the game ends. What is the average amount such a player wins?
We do the same thing kind of that we did in the price thing. We add all the possible on the left and the right.
That's right. We add up all the possible numbers and divide by how much?
26, which is I forgot what is it, 26?
Okay, so let's do it. 1 million plus 750,000 plus 500,000 plus 400,000 plus 300,000 plus 200,000 plus 100,000 plus 75,000 plus 50,000 plus 25,000 plus 10,000 plus 5,000 and 1,000 and 6,000. 6,000 plus 750 plus 900 plus 600 plus 75 plus another 75 plus 16 plus 0.01 divide by 26. So the average amount would be $114,169.85. And that's simply by adding them all up and dividing by how many outcomes you have. Does that make sense?
Yes.
Yep.
Okay. Now, one player got to the point where there were only 4 briefcases left unopened. They were $75, $5,000, $500,000, and $750,000. And the people who run the game said, you know what? We're worried that you might have the 500,000 or the 750,000. So we're going to give you, if you want right now, we're going to offer you $212,050. Take it or keep playing. Now, if you keep playing, maybe you'll end up with 75 or 5,000, which would indicate you just did a dumb move. Or maybe you'll end up with $500,000 or $750,000. You did a great move. The question is, was $212.50 a fair offer?
No.
And if not, can you tell me why not? And don't just say, by the way, because if it was fair, the TV show would never have done it. Be a little more specific. If it's not a fair offer, tell me why it's not a fair offer.
Because it's still below the average of it.
Well, the average was 114,000, wasn't it?
Well, I mean of what the cases that are open or unopened.
So yes, if you look at the 4 unopened cases, 75, 5,000, 500,000, and 750,000. The average of those 4 unopened is 313,768.75. So this means in the long run, if I kept playing with those 4 briefcases over and over and over and over again, I would win on the average $313,000. And they're only offering me $212. Of course, they're not going to offer me $313 because otherwise they'd probably be out of money pretty quick, right?
That's over 100,000 less.
They're offering me about $100,000 less. Now, suppose that you actually opened up. You said, you know what? I pass. And you opened up another one and it contained $750,000. Leaving you with 75, 5,000, or 500,000. What will be a fair price now when you only have these 3 options left?
168,358.3 bar.
And where do you get that from?
I added the 3 and then divided by 3.
Yeah, so now a fair price would be $168,000, 358.33. Of course, they're not going to offer you that much. What will they offer now, you think?
Well, they dipped us 100 grand on the last one, so about the same, so 68,000.
Somewhere in that vicinity, I would imagine. All right, here's another one. For each carnival wheel below, the player gets the number of dollars shown in the sector that ends up on top. Or in the case of the one on the right, wherever that tick mark lands. What will be a fair price to charge the player to spin the spinner once? Let's do the one on the left. What's a fair price? $4.50. Can you tell me? Oh, that was quick. That is correct, by the way. 450 is right.
I got 450 by adding all the possible ones that it can land on and dividing it by 8 because it has 8 possible it can land on.
Wonderful.
And then,
1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 divided by 8 gives us $4.50. If you were the carnival, how much would you charge for this game? What would he charge?
Maybe like,
Like
well, I would charge like 3, but knowing a carnival, they would charge like 5.
Wait. You would charge 3 when the average payout is 450?
No, like
Well,
650.
because there's-
Hold on. This means on the average, the players are going to win $4.50 every time they play. If you charge 3, you're basically saying, I'm going to lose $1.50 every time you play. Are you with me here?
Yeah, I see.
Okay, so tell me again, try again. What's the smallest that you'd be willing to charge?
Okay, so then you would probably charge like 5 or 4.
Well, not 4. 4's already too little. But
For sure, no less than 5, more like 6 or 7, right?
well, but think about it. You're charging $7 and there's only one number higher than that. Would you pay $7 to play a game where you're more than likely not to win $7?
Oh, I see. So 550 then.
Well, if you play 450, then they don't win, right? So there's got to be like a sweet spot. It's got to be.
Oh, you have to make around double. So wouldn't it be like 9?
No, wait, hold on. You walk up to a game and they say, here are the numbers 1 to 8. We will give you $1 for every number you get, and it's going to cost you $9 to play. So basically, oh, okay, here's my $9. Now you give me back at most 8. Does that seem reasonable?
Okay.
No.
No.
No. So
I
that
think
means,
6.
okay,
50
so
is smaller, 550.
even 6, I think. I mean, for me,
Yeah, it has to be like
I charge like $4.75. I mean, just a little bit to make a profit, but if it's too much, no one's going to play.
Yeah, I see it now.
All right. If I'm charging $5, I mean, that's like the limit. I couldn't imagine anyone paying $5 for a chance where you're more likely to win less than 5 than you are to win more than 5. Does that make sense? Yes, no, everyone with me?
Yep,
Yeah.
makes sense.
Okay. What about the one on the right? What would be the fair price for this one?
$3.40.
$3.40. It's good. Very quick. $3.40. So what would I charge here to play? Probably no more than $4. Probably no more than $4. Anything more than that, people are just not going to play. Does that make sense? The difference between, fair value and what people would do, practically. I hope it makes sense. Anyways, so expected value. So everything right now, every example that we did so far was very straightforward in the sense that we were able to add up the number of possible outcomes. We divided by how many there were. We got the right answer. Unfortunately, that only holds if the outcomes are not equally likely. Sorry, if the outcomes are equally likely. What do you do when they're not equally likely? So in this case, we need a more general formula, and we have this idea of expected value. It starts by making a probability distribution table. Remember what that is? Every possible outcome and the likelihood of getting every one of those outcomes. And then what we do is we multiply the outcome times its likelihood. We do that for all of them, add them all up together, and that's our answer. That is the expected value. Every possible outcome times the likelihood of getting that possible outcome, all added together. So let's do an example to demonstrate that. On a scratch-off game card given out by a fast food restaurant, you have 1/3 chance of winning a soft drink worth $1.25, a 1/2 chance of winning nothing, and a 1/6 chance of winning a hamburger worth $1.60. So let's fill out the table here. What number should I put for each section? Soft drink. What number should go there?
125,
How much? I'm sorry?
125,
$1.25. That's the value. Nothing. What number should go there?
Point or 0,
0. That's the value for nothing. And a hamburger, what's the value for that?
160.
160. Now, what is the probability of getting a soft drink?
2/6
For
or
a
1/5?
1/3. What's the likelihood of getting nothing?
1/2.
1/2. And what's the
1/6.
likelihood of getting a hamburger? 1/6. Okay, so the goal here is to calculate the expected value. So what do? We multiply every outcome on the left by its probability. And then we add them. When we do that, what do we get?
$2.85. If you add all the values.
No. You got to multiply, and then add. You don't just add the values. You got to multiply every value times its probability and then add those numbers.
So it's gonna be 1.25 times 1/3, and then add it with like 1.60. And then to
Times-
1/6, right?
Times 1/6. And what do you get?
Oh, okay. Give me 1 minute.
Okay.
.69. I think I did it wrong.
I got close to that, but not quite.
Wait, so what numbers are we multiplying? The 1/3, 1/2, and 1/6?
We multiply 1.25 times 1/3, 0 times 1/2, 1.60 times 1/6, and then we add those three numbers.
Got it.
.68 bar over the 3.
0.683 bar would be the expected value. So I should expect,
Oh, so I couldn't round up.
nope, they don't round,
Oh, okay.
don't round, 0.683 bar. Here's another one. The chance of being having, okay, no grammar here, but anyways. The chance of having your bicycle stolen on the CSUN campus is about 1% per year. Suppose you want to buy insurance that will pay you $500 if your bike is stolen. The question is, what should you pay? What should you pay? Let's before we go to the math, let's see what people's intuitive idea is. There's a 1% chance that your bike is stolen. And if it is stolen, you want to get paid $500. What should you pay for that insurance? Anyone? Anyone? Intuitive. Forget about rigorous math. Just give me an idea. What should you pay for that insurance? What would you pay if there's a 1% chance your bike would be stolen? Would you even buy insurance if there's a 1% chance?
No.
No,
Okay.
No.
Well,
maybe
suppose-
$25.
$25, okay.
Maybe.
Maybe 25. Anyone else?
We're like $5. Like a month? It is monthly, right?
Per year. No, per
Per
year.
year?
per
Oh,
year.
then I'm with, yeah, I'm with him, like $25.
$25.
Yeah.
Okay. All right, well, let's take a look. Let's make a probability distribution table. And that gives the possible amounts the insurance company will pay you. So what are the amounts that the insurance company will pay you at the end of the year? All possible scenarios. What are the amounts that the insurance company will pay you in all possible scenarios?
$500 or 0.
500 or 0? Do we agree? Yes?
Yes.
Yes.
Now, what is the probability that they're going to give you $500?
0.01.
0.01. And what is the probability that they're going to give you $0?
0.99.
0.99. So what is the expected value that they give you?
I got 5.
5. Okay, the expected value is $5, which means the fair price would be $5. Let's think about why. If 100 people give the insurance company $5, how much did the insurance company just make?
500.
500. But then of those 100 people, one of them is going to have their bike stolen. And therefore, the insurance company is going to have to give that person how much?
$500.
Which means they break even. Agreed?
Agreed.
Of course, in reality, there's two things wrong with this. One, the insurance company is going to have to charge more because they want to make profit. Otherwise, what's the point? And two, remember, these are only averages. So it's possible that 1 year, 3 or even 4 bikes are stolen. They got to pay $2,000. So they better have some money in reserve to cover that just in case. Anyone know what type of data analyst deals with determining how much money they should have in reserve just in case? It's a specific type of scientist. It's called an actuary. Anyone know about actuarial mathematics? No? Oh. Anyways. Okay. So an American roulette wheel has 38 pockets, 18 black, 18 red, and 2 green, correct? Everyone with me?
Mm-hmm.
Yes.
You bet $1 on red and the wheel is spun. Now, there's 18 black. There's 18 red, and there's 2 green. So what's the likelihood of getting black? What's the likelihood of getting red? And what's the likelihood of getting green? Oops. What is the likelihood of getting black?
18 out of 38 or 9 out of 19.
Okay, I'll do 18 out of 38 to keep the original numbers. 18 out of 38. And what's the likelihood of getting red?
It's the same.
And what's the likelihood of getting green?
2 out of 38.
And what do you win if you get black? And what do you win if you get red? And what do you win if you get green? How much do you make?
I
If-
make $1.
Huh?
isn't it? You make $1, like the actual payout is 2, but I'm paying 1, so my gain is $1.
Okay, so if it's red, which is what you bet on, your gain is $1. How about if it's black?
That would be 0 because I didn't bet on black.
Right, but I did bet on red, right?
Mhm.
So I lost $1 if it's on black. Agreed?
Yeah, makes sense.
And what about if it's green?
-1 as well.
-1 as well. So what do I expect to win on any specific roll? What is my expected value? What is my expected value? Number, multiply, 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 add. Anyone? All right,
-2 over 38.
I got -2 over 38,
Yeah, that's what I said.
which, okay, was approximately what in dollars or in cents?
Let me get my calculator.
I did it, -0.053 approximately,
Perfect.
which means you expect to lose approximately a little more than 5 cents per round. It's 3:15. I don't want to go over the limit, so we'll stop here. But we didn't quite finish chapter 7, so we will finish chapter 7 on Thursday and then move forward. Any questions on anything we did?
Just real quick, what was the answer that you got? I just want to confirm mine.
-0.0526.
-0.025. Okay, thank you.
You're welcome. All right, everyone. I'll see you on Thursday.
See you Thursday. Have a great day.
You too. Bye-bye.
Thank you, Professor.
You're welcome.
Professor, when will the next quiz be? Or do we didn't decide that yet?
Yes, it's this coming Thursday.
This coming Thursday is when you're gonna release it?
Yes, after class
Okay.
on 5 and 6.
And then the midterm is gonna be next.
Next
not
weekend.
this-
Next weekend.
Next weekend.
Next week.
Great, thank you.
You're welcome.
Thank you.
You're welcome. Anybody here? All right, I'm gonna stop recording.